about inheritance, what it is, and why it's useful. This is part 4, I believe, of week 13. And we're just going to get a general introduction into what inheritance is, how we can use it to make our code more efficient, right? So basically, and I think you guys have had some experience with inheritance at this point already, it allows us to create classes from existing classes. And the new classes contain the data and the behaviors of the existing classes. But then, we reuse or inherit all those data and features that already exist. But then we can also add to them, right? It wouldn't be very useful if we just reused it and it was the exact same as a duplicate. We can also add to them and make our newly created class unique. So the new class is going to be based on the existing class, right? But we can tweak it to make it more specialized, and we can do this without modifying the source code of the original class that we created, right? So, for example, there's many applications where you could design your solution to use inheritance. Sometimes the relationship is unclear, and other times it might be more clear. This slide provides examples of related classes. So in a video game application, you might have a player, enemy, level boss, hero, super player, and you find the relationships between those so that, a hero might inherit from a player, an enemy also might inherit attributes from a player, and so on. So let's take a look at an example with accounts, with a banking account. So here we can see our application has several different types of accounts. We have account, savings account, checkings account, trust account. And we might have a basic account that has a balance and a way to deposit and withdraw funds, but we also might have a savings account object that has a balance, but also an interest rate as well. So we can see it has the same functions or methods or attributes, but it also has a little bit of its own customized code. The checking account also has these same attributes, but it also requires you to keep a minimum balance. And then a trust account would have an interest rate just like the savings account, but maybe it's a different value. Maybe it's a much higher interest rate because it's a trust account. So what would this look like if we were to build this in C++ without using inheritance? Well, there'd be a lot of code duplication. For example, we would create a class for each of those objects, right? And each of those objects would contain the attributes that we had on the last slide. So balance, deposit, withdraw. But as we go through this, you can see on the savings account, balance, deposit, withdraw, I'm rewriting a bunch of code. And, code duplication is the first sign of bad programming. So this would work, but it'd also be a lot of work, and it would be a lot of wasted effort. So why don't we look at an example with inheritance where we can use some of the data that's in common between these classes? So here is an actual example of the proper C++ syntax using inheritance. And we're just going to focus on public inheritance. We won't talk about private inheritance in this class. It's much beyond the scope of what we're learning. But let's just look at this from a conceptual view at first, and then just so you can understand the concept of inheritance and code reuse. So here we have our account class, right? And it has these properties: balance, deposit, and withdraw. And we can see here, as we're inheriting from account on our savings account, that we're going to inherit balance, deposit, and withdraw implementations from the account class, right? And now all we have to do is simply add the interest rate attribute to this class, right? And a specialized withdraw method, maybe. If we wanted to override this withdraw method, we could specialize it there. So here I just have to write interest rate, and I don't have to include all of these because they're automatically included with my inheritance. Now, it's the same idea as the last example with the checkings account, except now I have my minimum balance attribute or a checking fee. And then I can also give a specialized withdrawal function to this class, but I'm inheriting from the account class right there. Finally, the trust account adds an interest rate here and implements some of that logic, as well as a withdraw method that supports that business logic. And we can see that these classes are now all interrelated, right? The savings account, checkings account, and trust account all depend on the account class. And so here we have what's called an inheritance hierarchy. So some terminology. You have what's called a base class in inheritance, which is the class that is being extended or inherited from. Sometimes people call it a parent class or a superclass. And then you have the derived class, which is a child or a subclass. This is what's being created from the base class. So in the last example, this would be account, and this would be savings account. Okay, so here is an example of a class hierarchy. So maybe this would be account, this would be savings account, checkings account, trust account, right? Here we can see that class A is not being derived from any other class. So it's also known as the root class, right? So we can call it the root class, we can call it the base class, parent class, whatever you use to remember. Now, B is derived from A. C is also derived from A, okay? D is also derived from C, and E is derived from D. So here we can see the hierarchy. Notice that the higher up we go, the more general our classes are going to be, and the lower we go, the more specialized they're going to be, the more custom functionality each class will have in it. Also notice the relationships in this example. So B is an A, it's derived from an A, right? And A, sorry, B is derived from A, C is derived from A, D is derived from C, and E is derived from D. Okay? So C is also an A, so B is also an A. They're both derived from the same class, but that does not make B a C or C a B, right? They're going to be different. So they're both derived from the same class, as well as E and D are derived from A. But notice that E is also coming from C here, right? So since inheritance is transitive, sorry, E is also technically coming from A. It's going to inherit some of A's features, technically, all the way up the chain, right? It might be really specialized at this point, but technically it's transitive, so all of these features will transit down through the hierarchy. There's no inheritance relationship between B and C. That's important to keep in mind, right? This could be completely different. Hopefully that makes sense. All right, and in this example, we have a root class person that is the most general or abstract class of the class hierarchy. And we can see a student is derived from person and employee is derived from person. So they're both person, right? They inherit all of the attributes from the person class. We can also see that faculty, staff, and administration are derived from employee. And so that means they're all employees. And if an employee is a person, then also faculty, staff, and administrators are also persons, right? So they would inherit all of the attributes from person. Notice student is not an employee. So he's not in that class hierarchy. A student will not get the employee attributes. A person is not necessarily an employee because they could also be a student. So this is just really helpful to keep in mind. It's called a class diagram. It's a type of unified modeling language, or UML. It's very helpful to understand class hierarchy. Okay, so this is how we can actually derive a class. This is the syntax for deriving a class or inheriting a class. So you do whatever the base class is, right? So this might be person. And then whichever class you want to inherit from the base class. So you'd have maybe this would be employee, so class employee. And then you can put an access specific modifier here. So public, private, or protected. We're only going to be covering public, right? So it always will be public and then, person. So this would be employee, public, person. So we saw it a couple slides ago there. So what these access modifiers actually do, there's three different types: public, private, and protected. And it's actually very different, this type of inheritance, from any other object-oriented language. Most object-oriented programming languages only support public inheritance. So public inheritance is the most common form of inheritance. And you see that the most often in C++. It establishes an is-a relationship between the two classes. So it's fully derived from its base class. And it's the type of inheritance we'll focus on in this course. Basically, private and protected establish a derived class that has a base class relationship, which is something totally different. And it's often used to implement one class in terms of another. And they are beyond the scope of what we're able to cover in this amount of time. So we just won't worry about private or protected. at this time. Okay, so another example of how you would actually derive or inherit a class in C++, if we wanted to inherit all the features from account from into our savings account, we would do savings account colon public account. And now savings account has all of the class members that account has. So savings account is a account. All right, and to create an object of a class or a class that you inherited from, well, we can do that the same way we've always done it. Account, just like this, with an empty list initialization syntax. You can also do it with a pointer, right? And now we have access to all of the methods within account, deposit and withdraw. And then we can also delete it if it's a pointer on the dynamic memory allocation on the heap. Now, how do we do that with an account that we've inherited? So it's a savings account from the last slide. Well, same thing, savings account, and then you just make an object of it. And now savings account is also an account, so it also has access to the deposit and withdraw method, right? Okay, so that is how inheritance works in C++. Hopefully that helps, establish some foundation in what inheritance is. I know you guys had some experience with it before, so if you want to get your hands on with C++ and try it out, then by all means, I encourage you guys to challenge yourselves and do that. I can give you some of those challenges. They won't be for marks, unfortunately, at this point in the course, because I want you guys to be preparing for the exam next week. But if you do, just let me know and I can post code up to Blackboard for that. That's all that I have for today for new material. So I'm going to end the recording here. I just muted myself. And then we'll have a chance to study, if you guys have any questions, to study for the final exam next week.